All right, the process that we left off with was you got several colors coming in. You got a single color being reflected. So we see this as red. We see this as blue because in this case, the green and the red light are absorbed, but the blue light's reflected. So what we're doing is we're removing a lot of the colors from the white light, and we only get one color resulting after this reflective process occurs. This is called color by subtraction. What we want to do is take a look at something else, color by addition. So what ends up happening is that you can take a single location and it may be emitting multiple forms of light from that location. If you think about your printer at home, if it's a color printer, and most people do have a color printer at home, you usually have two cartridges that you need to replace on the printer. You have the black cartridge and then you've got the colored cartridge, but the colored cartridge only consists of three colors. And from these three colors, somehow that printer is able to create any color at once. Now, occasionally you can demonstrate this effect with crayons. If you take a look here, I've got my yellow and my blue. And if I overlap the two, it's going to end up coming out. Oh, let me actually color it in. Is that you're going to see something completely different from both of them, right? You're going to see green. So what's happening here is green photons are not being emitted from this piece of paper right here. It's blue photons and yellow photons. But our brains record those two simultaneously, and for some reason our brains say, hey, that's green. Now there is such thing as green color, right? So there's another way we can get green, and that would be for our object just to reflect actually green light. But this becomes the other way to form colors. This is called color by addition. And sometimes you're going to get weird colors formed when you layer these various primary colors on top of one another in different forms. So for example, if you combine blue and red light, you get magenta. If you combine green and red light, you can get yellow. If you combine blue and green, you can get cyan. So it's very interesting the way these things end up working. And talked about magenta, right? If you take a look here, I don't know if I can read this off this, but not through the screen, but this says it's cotton candy. And basically, if you're looking here, this is pink, right? This color is totally fake. It's not real. The reason I say that is there's no pink photon. There's no such thing. You're not going to find it in the rainbow. This right here is completely in your head. What's happening is you have different forms of light coming in. Most likely blue and red are being reflected. So we got all different colors of light coming in. I could probably do the full spectrum here now that I've got the crayons. Red, orange, yellow, green. Where's indigo? This is indigo. Indigo. And violet. Right? All these things are coming in. What's most likely happening is you only get a few of these colors reflected. And what's going to end up happening is that we're forming color in two ways here. We're going to form color by subtraction because we're removing a lot of these colors. It's absorbed by this material. But in addition to that, we're also going to get maybe the red and the blue light reflected simultaneously, and what that's going to do is give us some sort of pinkish color in our brains. So the way colors are formed are a lot of times a figment of your imagination. However, there are real colors, and any color that you would see in the rainbow is real, but any color that you wouldn't see in the rainbow has to be formed by some addition process here. So hopefully that clears things up, or maybe it confused you even more.